Hi guys. So today I thought I could help you guys out who need it with the power and work assessment. It says assessment, but it's really just a worksheet. So don't worry, it's not a test. So it says please answer in complete sentences, so note that, and show work on calculator type problems. So you can use a calculator if you need to, but you're going to find out that you really shouldn't have to. Don't forget to label, right, your units. So what you should have is this out in front of you. What you should also have out in front of you is this. And this is the work you did yesterday. You simply, super easy, just copy the information just so you have your very own list of formulas in your very own handwriting. You are going to be referring to this to do these problems. Okay, so the first question is, what is the work formula equation that you learned about yesterday during your reading? And if you go to your formulas to know and use, you can quickly see work. Okay, work is when a force moves an object. And the formula to find out how much work is used to move an object is going to be force times distance. So work equals a force times the distance that it moves. And that's number one. Okay, number two. What is the power formula equation that we read about in class yesterday? So power equals work divided by time. And we know that this is written like a fraction because a fraction is a really simple division problem. You could also see it like with a slash, and that would be okay too. Now, the thing about this is the unit of measure is called a joule. And this unit of measure is called a watt. Okay? So the unit of measure for work is a joule. And the unit of measure for power is a watt. Okay. Number three. John uses 50 newtons of force to push a shopping cart 10 meters. How much work does he do in joules? So they want to know joules. And we can remember that a newton is very closely related with a force. Okay, so all we need to do with this is to find out work equals force times distance. So it's simply going to be 50 times 10. The amount of joules you would need would be 500 to push that shopping cart 10 meters. Okay, now I am writing the answers. You should, of course, be writing in a complete sentence. Number four, Liz does 4,800 joules of work, note J for joules, in climbing a set of stairs. If she does the work in 6 seconds, what is her power input? So now you have to use the power equation. Power equation is right here, work divided by time. So her work, 4,800, divided by time, for 6 seconds to do it. Okay, this of course cross reduces, or I shouldn't say cross reduces, reduces down to 8, because 6 goes into 48 8 times, you keep your 2 zeros. Okay, so for number 4, her power input would be 800, power is watts, 800 watts of power. Okay, for number 5, how much work is required to pull a sled in order to generate 30 watts of power in 5 seconds? Now this time they give you the wattage, and this time they give you the time. So we kind of have to plug in a variable here to figure it out. So we want to find work, right? So we want to find the joule. Okay, so let's do some amount of work, we don't know what, in 5 seconds is going to equal 30 watts. Okay, so now I just have to think, what divided by 5 is going to give me 30? Okay, and the answer to that is 150. I told you you wouldn't need a calculator, you could all do this in your head. Joules is the unit. Okay, so I'm going to erase so that we can give you more space. Okay. Alright. So now we are on number 6. So 1 Newton meter is equal to, we have that right here, 1 joule. Okay? 1 Newton meter is equal to 1, oh, I picked the wrong one. I'll get that marker. Number 6 is equal to 1 joule of work. Okay. Is your arm getting tired? Sorry, my husband is videoing this and his arm's getting tired.
Mm-hmm.
Okay. Number 7, power is usually measured in, we discussed this, right? Watts. And you could look at your graphic organizer to easily see that. It's watts. Okay. Number 8 is kind of funny because they're putting in here, they're implying that gravity is at work, and that kind of changes things a bit. But we're going to keep it super simple. We're going to say how much work does a 50 kilogram person on Earth do if they lift up a barrel 2 meters above the ground? Okay, so we're just going to keep it simple, and we're going to say 50 kilograms of force times distance, which is 2 meters, which will give us 100 joules. Okay. So let's go down to number 10, and this is kind of a cool question, right? So the question reads, explain why would the amount of power change after climbing stairs twice at different speeds? So this is what you did yesterday. So think about that. Why do you need more power to do something twice as fast? Okay, so I'll let you fill in that answer. That's your own answer. Okay, now number 11 is pretty cool too. It says, and don't get tricked by it, as the length of time it takes a student to swim 100 meters decreases, the power by the student, what? You have decreases, increases, or remains the same. So let's think about it. The work is staying the same. He's doing 100 meters, no matter how fast or how slow he gets there. He's going 100 meters. But if he can do it twice as fast, then he's working twice as hard. So if his time decreases and goes down, that means the power must increase because he has to work twice as hard to go twice as fast. Okay, last one, flip over, number 12, on the back. How much work is done on a 300 Newton suitcase lifted 5/10 meter? Okay, again, work is going to be force times distance. Okay, and I know 5/10 is really, can look like that, correct? Which is really 1/2. So what is 1/2 of 300? 150 joules. Okay, so I hope that helped you, whether you just checked your answers or whether you worked along with me. I hope this makes a little bit more sense in terms of how you measure work, power, and how mass and distance and force are all involved. Okay, bye.